Thank you for the introduction. So the title of my talk is Trust-Based Approaches Towards Enhancing Internet of Things Security. It's a systematic literature review paper. So a little bit about me presenting this paper today. My name is Oghenetejiri. I'm currently a PhD candidate of computer science at the Nottingham Trent University in the UK. Some of my research interests include cybersecurity, trust-based systems, cloud computing as applied to multidisciplinary research. So I've structured this presentation as shown in the content here. So one will go through the introduction and then the contributions of the study, as well as the research questions. Next will be the aims and objectives, and then the related works, methodology, the results and findings, as well as the conclusion, and then there's, excuse me, the opportunity for further questions, and finally the references. So let's get into it. So introduction. In recent years, there has been an increase in the number of Internet of Things devices that are being adopted by businesses worldwide. And it has helped streamline processes for most businesses worldwide. It has helped increase the efficiencies for these businesses. And due to the very nature, the unique nature of Internet of Things devices, they can be found pretty much everywhere. They're very common. And as a result of that, it has led to a number of cyber attacks. It has led to an increase in the volume and frequency of cyber attacks worldwide. And to address some of these cyber attack challenges, researchers around the world have come up with several different ways to try to mitigate the effects of these attacks. But there is also that need for an enhanced way to kind of mitigate attacks and cope when an attack occurs. One of such proposed approaches is by means of trust-based systems. So one which can not only identify, but also collate and make cybersecurity decisions based on trust values and reputations. And this was one of the motivations for this research paper. So the key contributions of the study are one, a systematic literature review on the state of art in the literature of trust-based approaches as applied to cybersecurity of Internet of Things. And then next, we carried out an analysis of trust-based systems and techniques. From the reviewed literature, we grouped the types of trust-based systems into three major categories. One was observation-based systems, two, knowledge-based systems, and the third category, cluster-based systems. An analysis of the challenges associated with each of these techniques was also highlighted in the paper. And then another contribution was a review of some of the design approaches, key performance metrics that are required for evaluating not only the performance, but also the level of efficiencies of some of these trust-based systems, as well as the advantages. So what are the benefits? What are the pros? What are the cons of some of these trust-based cybersecurity techniques? And then finally, open research directions were highlighted as part of the study. To help guide the research, several research questions were put forward, three of them in particular. So the first one is, what is the state of art of trust-based systems in addressing cybersecurity needs in IoT environments? So just trying to understand what the current research is, what are the new trends in terms of trust-based systems, and what are the cybersecurity needs in IoT environments, trying to understand those. And then the next question is, what metrics are essential for evaluating and calculating trust within IoT networks? So what are the key metrics that researchers are considering when trying to establish and evaluate trust within IoT networks. And then finally, what are the open issues and future challenges of trust-based systems in IoT? The aims and objectives of the research were to, one, conduct a systematic literature review on the cybersecurity challenges specific to Internet of Things technology. And the second aim was to investigate and then classify the different types of trust-based systems and techniques, as well as their various applications as related to Internet of Things. And then the third aim and objective was to identify specific issues, future challenges, and future research directions in terms of trust and reputation-based systems in Internet of Things technology. Several related works were considered as part of the research. I have included a brief overview of some of the works that were reviewed as part of this, this research. In the work by researchers Tan and Asman, they did present a study on industrial Internet of Things, security architecture. They analyzed the gap between the security requirements of industrial Internet of Things, as well as the deployed countermeasures. Although they did carry out a classification and highlight several open issues, there wasn't a clear highlight of how their paper selection was done, or what years were considered, or what specific publication years were considered. In the work by Dean et al., they did examine several Internet of Things trust management technologies and strategies. They did do some analysis of advantages and disadvantages, and provided a description of each of their approaches. But again, there wasn't a classification done or taxonomy in their work. They did not highlight any open issues, and their paper selection process was not included as well in their research. And in the work by Shevani and Mastari, their work was mainly focused on exploring trust security in the context of IoT. They narrowed it down a bit to mobile ad hoc networks, and in terms of addressing the challenges associated with managing trust within this Internet of Things systems. They carried out a classification in their work, but again, they did not elaborate on their paper selection methodology or which specific years were considered. And then in the work of Shans and Gupta, it was a survey paper. Several categories of cyber attacks were reviewed. They did highlight several of the security vulnerabilities in Internet of Things and industrial Internet of Things devices and networks. And yes, they carried out an analysis on several countermeasures. They did do some classification in their work, and they did highlight open research issues. But again, as was a common theme in most of the reviewed papers, there wasn't a clear methodology on how they selected the papers they reviewed or surveyed, and the years considered in the publications wasn't made available, and it was not a systematic literature review as well. And then in the final one included in this presentation from Muzamal et al., they did an investigation on security challenges associated with Internet of Things networks, as well as routing protocol for low power and lossy networks, RPLs. It was mainly focused on trust-based secure routing, so it was a very narrow scope in their research. But again, there was no classification, neither were there any open issues highlighted in that paper. The paper selection, again, was just not elaborated upon, or the years considered specified. So the table in this next slide just shows some of the differences in this previous survey papers and review papers and how our work differs from all of this. The main idea in our paper was trust-based systems. We carried out a clear classification Several open issues were identified in our paper. Our paper selection process was clearly elaborated upon in our methodology, as well as the years considered, which was from 2010 up until 2023, when the research was done. And then this brings us to the methodology part of this research. So the systematic literature review was done in accordance to the Barbara-Kitchenham's method. So 5 databases were identified for this research. So one was Scopus, IEEE Explore, Science Direct, Springer, as well as Google Scholar. So we carried out a search across all 5 databases. There were 50 distinct combinations of keywords which were used for the searches. And those resulted in an initial result of about 1,360 papers. And upon refining the search criteria, so we narrowed down the scope in certain databases to computer science and computer engineering related papers. And then we narrowed it down according to the years of the publications. And we strictly selected conference papers or journal publications. And that resulted in a refined number of papers of 125. And then when duplicates, because there were several duplicates in those results, when we removed the duplicates, we had 46 papers. And then we ran a final exclusion and inclusion criteria by reviewing the abstract and conclusions of each of those papers. And that left us with a selection of 18 papers. And then we finally did some forward snowballing based on those 18 papers and backward snowballing. And that left us with 3 and 2 papers respectively. So the final selection of papers for this review was 23 in total. The chart below just shows the trend in terms of publications of trust-based systems as related to Internet of Things technology. It shows a fairly consistent trend within the last 5 years that there's a lot of interest as against the previous 5 years of publications in Internet of Things technology, as well as trust-based management techniques for mitigating cyber attacks common to Internet of Things. It also shows that a lot of research is still needed in terms of designing specific types of trust management systems that can cope with emerging attacks, because the attacks keep evolving year on year. And it also shows that whilst there's an increase in the number of publications, there's still a lot of gaps for several open research areas. In the papers reviewed, security and privacy considerations have repeatedly emerged as pivotal themes. Most of the results have focused on security and privacy. So it's been like the most consistent theme. We had a keyword analysis of some of the common keywords identified in the papers reviewed in security and privacy were like some of the top words. Privacy considerations in the design of Internet of Things networks from the perspective of data provenance has led to a lot of scalability issues, and that's one of the most common future research areas identified from the publications. Exploration of trust-based techniques as a means of sorting out the scalability issues, because what's been noticed is as the number of nodes or devices in an Internet of Things network increases, most of the systems or the cybersecurity measures in place tend to struggle with the scale. So that's a very interesting future research endeavor. And then the examination of several cybersecurity data sets and trust-based systems by investigating novel methods of cloud security is another emerging area of interest. Communication and privacy issues again, is also another emerging area of interest. And then the results also revealed that the concept of trust is multidimensional. It's been defined in so many different ways across multiple industries, from social sciences to philosophy, all the way through to technology. There's so many different definitions of trust, but in the context of this research, in terms of Internet of Things networks, Aldoa et al. Did define trust as the likelihood of a node adhering to expected behavior. So when a node departs from that expected or predefined or predetermined behavior, it's considered to be one that's a misbehaving node. And there's so many different reasons for that. Sometimes it could just be a selfish node. That means one which is trying to either conserve resources or preserve itself. Or it could be a malicious node, which means an attacker has gotten hold of the network and he's trying to, for nefarious reasons, attack the network. So another perspective of trust is the degree of belief in a node within a network of nodes. That means trust itself is reflective in nature. That means a device or a network node trusts itself. But then again, trust is also asymmetric in nature, such that because, for example, node A trusts node B, doesn't necessarily mean that node B trusts node A. So those are just some of the common characteristics of trust as found from the results of the review. And then we carried out a classification of the various types of trust-based systems and techniques of Internet of Things networks and devices. We grouped this into three major categories: so observation-based systems, knowledge-based systems, and cluster-based systems, as shown in the figure below. Some methods do use the hybrid system by combining two or more of this. But in terms of the observation-based systems, there were two different types from the reviewed literature, the direct and the indirect observation-based systems. So for the direct-based systems, these systems primarily depended on, or the nodes on the network primarily depended on making trust calculations and computing trust based on direct observations. And then in the case of the indirect system, they relied on experiences shared by neighboring nodes or neighboring devices on the networks. One benefit of the observation-based systems is that they can easily detect when a cyber attack is happening, so they're very quick to detect cyber attacks. But then again, the drawback is as the network becomes larger, or as the number of packets flowing through a network increases, it leads to additional overheads on the networks, and that dramatically reduces the throughput and efficiency of the network. And then in the case of the knowledge-based systems, there were two types identified from the review literature, the symmetric and the asymmetric knowledge-based systems. For the asymmetric system, not all the nodes on the network had access to the same number of information, which led to several significant issues from the models considered. And then for the symmetric systems, all nodes and all devices on the networks have access to all trust-based information at the same time, which led to a more secure network from the models considered. Meaning if an attack was happening on one section of a network, or if a node was compromised, all nodes on the network could easily detect that as soon as that happened, and they could easily isolate the misbehaving node and carry out trust computation and trust calculations without affecting the general network. So this was considered to be one of the most secure methods, the symmetric knowledge-based systems from the reviewed literature. And then the final classification was based on the cluster-based systems. So these systems were designed primarily to have a centralized node or device, which was responsible for computing trust and calculating trust. So all the trust updation, trust propagation, and trust dissemination were being handled by just one node or device on the network. This is commonly found in wireless sensor networks, as well as VANETs. Some MANETs do deploy this method, but whilst it is great to have a centralized node or network handling all of the trust computation, the benefits are numerous because such networks or devices tend to compute trust quite quickly because it's centralized and allows all the other nodes on the network to function effectively and efficiently. But the major drawback with this approach is that once the central or computing node is compromised, then the entire network dramatically ceases to function, and trust calculations immediately cease. So these were some of the major metrics identified for calculating trust and for updating trust. Some other metrics identified in the reviewed literature included reliability, efficiency, and this leads us to the conclusion of this presentation. So trust-based systems are very effective for detecting and preventing cyber attacks. Whilst they can significantly improve privacy and security within Internet of Things network, there is therefore the need for future research and development in this area. It is very imperative. And as the Internet of Things technology continues to evolve, so will the threats, so will the vulnerabilities. Therefore, it is necessary to explore further development and enhanced trust-based techniques for Internet of Things. Several future research directions were identified as part of the research as well. So a scalable trust-based system for Internet of Things is one of the key areas for future research. Distributed denial of service attack. So a system which can effectively identify and cope with distributed denial of service attacks, especially for mobile ad hoc networks, is another future research direction. And then the use of blockchain in combination with trust-based systems is another future research direction, which was identified. And that brings me to the end of my presentation. Any questions for me?